Behavior Designer and the Ultimate Character Controller are integrated with each other, and this allows Behavior Designer to take control of the Ultimate Character Controller character. A character controlled by Behavior Designer can do anything that a character controlled by a human can do. This video is going to go over the Behavior Designer and the Ultimate Character Controller integration scheme, which gives a pretty good example of a moderately complex behavior tree. If you're not first familiar with the basic concepts of what a behavior tree is or some of the more common tasks, I recommend first watching the Intro to Behavior Designer videos. So I have this project open that already has Behavior Designer Movement Pack, and the Ultimate Character Controller integrated. We can also see that I've integrated the Behavior Designer Ultimate Character Controller integration, and with that it brought in this set of files. Under the demo folder there's this README, which basically explains the same thing, but it also says that the nav mesh must be baked before the scene can be played, and we can see that I've already baked the nav mesh. So I've opened up this scene and we can see that there are two different characters. There's Nolan and then there's Agent Nolan. Agent Nolan is controlled by Behavior Designer and Nolan is controlled by the player. In this case, I opened the first-person shooter scene, so Nolan will be in a first-person perspective with the assault rifle, but the scene is the same no matter which version I chose, and it just depends on which asset you have imported as to which scene you should open. The behavior tree is exactly the same across these four different scenes, and you can actually use the exact same behavior tree for both shooting and melee weapons. So let's go ahead and get started, and the best way to kind of see this, I think, is just to hit pause and play so that we can see what's happening on the very first frame. Now I already have Behavior Designer open, so let me go ahead and click on Agent Nolan, and I'll drag Behavior Designer in, and we can see that the behavior tree is active and any task that is green is currently running. And if we look at the behavior tree, we can see that really right now the agent is only patrolling. Remember that behavior trees evaluate from top to bottom, left to right. The higher priority task should be put on the left, and then the lower priority task should be put on the right. So in this case, the sequence task ran, then these three action tasks ran, and then there was this parallel composite task that is running two different branches. It's running this bigger branch that kind of has the main functionality, and then this helper branch. This bigger branch has 5 or 6 different sub branches, and the very leftmost sub branch, which is the absolute highest priority, is to find ammo if ammo is low. The reason why this is the absolute highest priority is because the agent can't do anything if they don't have ammo. If they don't have ammo, there's no point in even attacking because the agent can't attack. The next highest priority branch is to seek the target if the target comes within sight. And this branch has a lot to it, so this branch is kind of the main child branch within this leftmost parallel branch. The next highest priority branch is to search for the target if the target attacks the agent. And what this says is that if the player attacks the agent, then a hit event will occur and the agent will take damage. If the agent takes damage, then the agent should start seeking or searching for the source that caused that damage. And the agent will then start attacking that source, assuming it becomes within view because of this branch. Remember, anytime a lower priority branch is running, a higher priority branch can abort it or can interrupt that child or that sub branch, that lower priority branch, because of conditional aborts. I'm using on this branch a lower priority abort, which basically means any branch to the right of this sequence task can be aborted by this conditional task when it changes. So we'll see that canSeeObject is returning failure right now because of this X with the circle around it, but as soon as canSeeObject returns success, then it will abort any tasks or any branches that are to the right of it. This next branch right here will search for the target if the target is heard by the agent, and this basically allows the agent to search for a source if any sound is heard. This next branch will have the agent wander at the last known position of the target, and this gets set by a branch higher up in the tree, and we'll go over that in a little bit. The absolute lowest priority branch are these 4 different tasks, and this will basically make sure that the behavior tree is kept alive while the agent is alive. And in this case, if the agent has absolutely nothing else to do, then the patrol task will run. I always recommend having some sort of an active task that gets run just when the agent is idle, whether it's patrol or just idle even, or wander, just to have the agent doing something so when there's nothing to do. So that's the main functionality branch. There's also this little branch right here that gets evaluated every frame, and this will get the position of the target assuming this update position value is true. And this update position gets set to true in a couple of different cases. But right now, because the agent really hasn't done anything yet, there's no reason for it to be true, so there's no reason to update the position. So let's go ahead and hit play just to kind of see what the agent's doing. And we'll see, if we look at the behavior tree, we can see that this bool comparison task is running every frame, and it's returning false, so get position does not run. And in the other branch, we can see that patrol is still running. If we click on the patrol task, we can look at the different waypoints. And the first waypoint is right here where the agent first went towards. Second waypoint is at the end of the hallway, which is where the agent's moving towards now. And then this third waypoint is in the outdoor area. So right now, assuming the agent does not see the character and the character does not attack the agent is just going to keep patrolling. So let's go ahead and change that, and I'm going to start attacking the agent right away so that we can then see what happens. So let's shoot the agent and hit pause. So we can see after I shot the agent, we can see he's no longer patrolling, but he's starting to run towards me right now. So I am right here. Let me reduce the size of these gizmos. So I'm right here, and the agent is starting to run towards me. If we look at his behavior tree, we can see that the patrol task is no longer active, but these tasks within the seek branch are currently active. So let's go ahead and see what actually happened. And the very first thing that happened after I shot the agent was that this has taken damage task returned a status of success. Because of this lower priority conditional abort, it interrupted this patrol task and started running has taken damage, because has taken damage changed status from failure to success. Right now it's failure because some time has elapsed since he took damage, but in order for it to have been triggered, has taken damage would have returned success for at least one frame. After has taken damage occurred, the next task that was run is this get position task. And what this does is it gets the position of the target that took damage, or that it was taken damage by. Basically what the goal of this is for the agent to start wandering at the position that the agent was shot at. So I shot this agent at this position right here, and the behavior tree is going to get that position, and the agent will then start wandering towards me at that position. It does this by this set bool, because notice the bool value of true is being set to the wander variable. This is used within the wander branch down here, but let's not get there quite yet. We can then see that update position is set to true, and what that will do is it will trigger this bool comparison task to return success, so get position can run and can update every frame. The reason why this gets updated every frame is so that the agent will continuously update the position of the target. In this case, it's going to continuously update the position of me. This start stop ability task will start the speed change ability, which will basically make the agent run towards the target. And then we have a child branch right here. This child branch is sort of interesting, so let's go ahead and take a closer look at it. And this float comparison task will first determine if the agent is low on health. If the agent is low on health, we don't want the agent to start attacking a character because they're probably going to die easily. So we want the agent to first go ahead and get health. And it does that through this comparison task between the health variable and the float variable or the float value of 30. So if health is less than 30, this task will return success, and then it will start seeking towards the health pack location. This health variable is sort of interesting in that it's a property mapping variable, so it's not actually storing the raw value within the behavior tree. What it's doing is instead calling this demo agent.health property, which ends up getting the getting the health value from the ultimate character controller health component. So if we take a look at the demo agent component, which is towards the bottom of the character, and then we look at the script, we can see here's the health property, and what it's doing is returning the health value of the health component. The health component is an ultimate character controller component, and this is done just so that the ultimate character controller and the behavior designer values will always match up because there's only one value. We could also have synced the two values every frame so that the behavior tree value would always match the ultimate character controller value, but this is a much more efficient way of doing it. If we look at this health component, we can see that it has a value, or it has a health value of 70 right now. So because 70 is not less than 30, this task is going to return failure, and then these next set of tasks will run. You'll notice that the agent hasn't actually started seeking towards any point yet because this seek did not run. But right here we can see that update position is set to false and the target is set to null as well, so that basically it prevents the agent from remembering where the character is at, or the source that shot the agent is at. And the reason for this is that, remember, wander is still true from right here. So as soon as this branch ends, the wander branch will then pick up where it left off. And this bool comparison task will first check between wander and true, and in this case it was true, and then it will reset the update position value. And this is just done because the update position isn't always set to false when it gets to this point. And it will start to ensure the speed change is active, and then it will start seeking towards the last known position. The last known position isn't updated right now because update position is false, and that was set right here. And the reason for that is we don't want the agent to always remember or just like specifically track where the character is running. And this will basically it prevents the agent from cheating and knowing where the player or the character is at, even though they can't actually see him. So it kind of adds a little bit of realism to it. The wander task started to run, but you can see seek returned a value of failure, and that was because this can see object task is being reevaluated with the lower priority conditional abort, and because it returned or it switched statuses from failure to success, it then aborted the lower priority branch, which was this wander branch, and it started running. Now if we go through this, we're doing a little bit of cleanup. We're making sure that the can see target is equal to the target variable, and we do want the agent to wander if the agent loses sight of the character. And we also want to update the position again, just in case the character loses sight. Now you can see that there's this selector task which will first run the leftmost branch, which is this sequence branch. And the sequence branch has a self-conditional abort, which means that it's going to reevaluate any conditional tasks that are directly underneath it. So the conditional task underneath it is alive. And what this does is it makes sure that the agent only attacks the target while the target is alive. As soon as the target is no longer alive, this task is going to return a status of failure, and this branch will end. Because the target is alive right now, this selector task starts running, and the selector task will first run the parallel task. So let me zoom out again just to get our bearings where we're at. This parallel task will then do two different things. It will first run another can-see object task to ensure the agent or the target is within sight and is close to the agent. We don't want the agent attacking from extremely far away, but we want the agent to attack when it gets close. And in this case, close means this attack distance variable, which attack distance is a unit of 5 units. As soon as the agent can start attacking, this start stop use ability will play, or task will play, and that will do the actual attack. This actual attack occurs by starting the use ability, and the use ability will then attack the assault rifle, or will then say that the assault rifle should fire. After the assault rifle has fired, this wait task will play for 0.2 seconds, and it just gives it a little cooldown. So this is being evaluated every frame to determine when the character or when the target is within sight. And as that is going on, we can see that this branch is also running, and this branch will get the agent close to the target. There's a within distance task that is being reevaluated right now because of the lower priority condition, or because of the self-conditional abort. And what this task is doing is it's saying, is the target within distance, which is the target within this near distance, and this near distance has a value of 5. No, the target is not within 5 units right now. We can see that the two are separated by much more than that right now. And so that's going to return a status of failure. This failure status will then be inverted to success, so that the remaining branches can, or the remaining tasks can run, and this task right here is going to seek towards the last position. Remember, the last position was updated because of this set bool task, and this last position is the last known position of the character that attacked the agent. As soon as the agent gets within distance, this seek will this seek will keep moving on until the agent basically gets right over the target. Because the agent never can get right on top of the target, because you have two objects basically wanting to occupy the same point, seek is never going to actually get there. But within distance will return a status of success when it's within a distance of 5 units to the target. So this will return success, which will be inverted to failure, which will then stop this branch from running because of this self-conditional abort. So let's go ahead and hit play just to see this active. Okay, so we saw briefly within distance switch to success, just as we said that it would, and now it aborted this branch. The next branch ran because of this sequence task, and what this branch does is it keeps the agent within distance of the target. So if the agent is not within distance of the target, then let's see right here, or if the agent cannot see the target, then the agent will start seeking towards the target so that it's close enough in order to attack. This within distance up here will basically just have the agent give up if the target is too far away. Remember that wander is set to true right now. So if I look at my variables, we can see wander is set to true and update position is set to true. So if any point the agent loses sight of the target, the wander branch will start running over here, and the agent will then start wandering at the last known position of the character. So let's let it play a little bit longer, and you can see he's attacking. And now he attacked the agent, and he attacked the target, and now the target died. And we can see that this is alive task returned failure. So as soon as is alive returned failure, because the target's dead, this next branch ran right here, and this branch right here kind of just resets all the different variables so that it's back to the beginning. And now, because the agent has nothing to do, the agent is just going to start patrolling again. The patrol task will then have the agent patrol towards will have the agent move towards the closest point, and the closest point in this case is the waypoint right here. So we can see that the agent just basically keeps going back and forth to that waypoint, and eventually the agent is going to run out of ammo. So I want to get it to that point. He's just going to keep shooting me until he gets close to running out of ammo. And as soon as he does get run out of ammo, this float comparison task will return success, meaning that the ammo amount is less than, so the ammo amount, the agent now has less ammo than 5, and we can actually double check that by clicking on the agent and then looking at its inventory. If we scroll to the inventory, let's see wherever that is. I must have missed it. So here's the inventory. We can see that it has an assault rifle count, or it has an assault rifle bullet count of 0. So 0 is less than 5, so the agent is out of ammo. And because the agent is out of ammo, this branch right here is the absolute highest priority branch, and so it started to take over everything else. So even if I were to be able to shoot the character while he's going to seek to get ammo, it wouldn't matter because he's seeking to get ammo, because this is the absolute highest priority branch. As soon as he gets ammo, which the ammo location I think is up on that hill somewhere, this seek will return success, and then he'll start resuming his normal behavior, which in this case, it looks like, okay, so his normal behavior is to start wandering to the last known point, because when the agent ran out of ammo, it was currently attacking the player. The player hadn't died yet, and so it's going to keep moving towards that last known position. In this case, that last known position, I'm still standing at that position, so he's going to see me again and then start attacking. So this can basically go on forever. But this tree kind of gives a good overview of how behavior designer works. There's a lot of concepts at play here, and especially with the integration with the Ultimate Character Controller, this tree does get kind of complex, although once you really just have to go through it task by task to understand why it's doing what it's doing. So hopefully this video helped with that. So thank you.